Hello friends, welcome back to the data structure tutorial, and today we will be discussing about deletion of a node from the doubly linked list. Now, whenever we want to delete a node from the doubly linked list, so we need to check whether the given data is present in the list or not. And if it is not present, we have to tell the user that that particular data is not present in the list, so we cannot delete it. So for that we have created one function, that delete function is there, and we receive the data which is to be deleted. And for that we have considered the doubly linked list which is available with us, and we will be writing some elements into it. So let's say that we have this starting point whose address is suppose 500. We have a next node whose address is suppose 700. We have this node suppose address is 200, and this is the node with the address of 800. Every node will consist of some data, so I'll be writing some data into the each node, and those nodes are connected to each other in the doubly linked list way. So in every next and previous block we will be having the addresses of next and previous block. So here we will be having 700, here we will be having 500, here again 200, and this will be 700, so it will be connected to the previous one. Here we will be having 800, and here 200. The next field of the last node will be null, and the previous field of the first one is also as a null. So whenever you received some data, we have to check that data is present in the list or not. But before that, there is one more condition you have to check, that if your starting point is equals to null, if your starting point is equals to null, it means that you do not have a list. So you will be printing a message to the user that empty list. There is a empty list. And if it is not an empty list, it means that you have a list which we have mentioned here. Okay. Now suppose user has sent one data which is uh, like we'll consider that data is 9. User want to search that data 9. So we have to search whether that 9 is present or the not. So this is our previous field of every node. This is our information field, and this is our next field. So we will be checking that data by comparing with the information field of each node. So we have to visit each and every node and we have to compare that. So that's why we will be taking one pointer P, which will be start from your starting point. So we have assigned the address of start to the P. So this will become your P. Then you have to check whether the information field is equals to your data. If it is not equal, then move your P forward direction. So we have done this so many times while inserting a node at the different location in the doubly linked list. So we will be using while loop, while, and you will be checking P's information field. If P's of info of P, that P's info is not is equals to your data. If it is not is equals to your data, what you will do, you will move your P forward. So you will be moving your P forward. So how will you write? We will be writing P is equals to P of next. So the next address will be copied into the P. So current P's info is 5. Your data received is 9. Okay. And if it is not equals to, then you are assigning P's next to the P. So P's next is 700. So you will be assigning to P. So P becomes 700. Now current P's information is 7. So it becomes 7. Now 7 is compared with 9, which is not equals to, again P of next will be copied to the P. So P of next is 200, that will be copied to the P. Now P's info is 2, so this becomes 2. 2 is not equals to 9, okay. P of next will be copied into the P. So P of next is 800, so it comes to the 800. Then again P's info is 8, so this 8 will be compared with 9, which is not equal. So again P of next will be copied to the P. So what is P of next? It's null. So what is the new value of P? It is null. So what it means? If it is null, means the data is not present, this value 9 is not present in the list. So we have to display that message to the user, right? So we have to write one more condition here, that if you are continuously moving forward and somewhere if you found somewhere if you found if P becomes null, if you are moving forward and your P becomes null, what it means? That element is not found, right? So you can display one message that data not found. This is the condition to check whether the data is present or not. And if the data is present, so let's say we will do it again. So I'll be taking some valid data which is there in the list. So here you have to assume that you are taking some data which is there in the list. So instead of 9, we can take the data, for example 2. So your data is 2. Okay, starting address is assigning to P. So this is your P. Now P's info is 5. This is your current info. P's info is 5, which is compared with 2. That is your data which is to be searched. P's info 5 not equals to 2. Okay, condition is true. P of next is copied into P. So P of next is 700. So P will be moving forward. P's info is 7. Now P's info is 7, which is not equals to 2. So P of next again will be copied to the P. So P of next is 200. So that will be copied here. Now current P's info is 2. So it becomes 2, which is not equals to 2. It falls. So your loop will be stopped. So what P is representing? P is representing a node which is the node you want to delete, which contains your data, right? So this is just to search that particular data and you want to delete this node. This is how you will be searching the node throughout this linked list. Now we will be writing one condition for deletion of a node from the beginning of the doubly linked list. So if you want to delete this node, so your data must be 5. So whatever data you want to delete, you will be search first and then you will be checking one more condition. If that P which is representing a node which is to be deleted, if it is at the beginning, then what logic should be there? If it is at the end, what logic should be there? And if it is at the middle, what logic should be there? So we'll be writing independent algorithm for the same. So let us assume that the data which you have received is 5. So if data is received as 5, so what logic you will be performing? So I'll be just quickly erasing all the things. So data is 5 and you assign the starting address to the P. Okay, you come inside the loop that P's info is 5, which is not equals to 5, it is false, so it will not go inside the loop. So you identified a node which is to be deleted, which is represented by P, and this is the node which you want to delete. So if you delete this node, this is the condition that the deletion of a node from the beginning of the list. And how do you know that? If the address of P and the address of start are same, and if you found that element on that same place, so it means that this is the condition to delete that node from the beginning. Okay, and if this is the condition, then what you will do, you will be writing, if you delete this, so who becomes your start? This 700 becomes your starting point. Okay, and so you need to assign this address 700 to the start. So how will you assign it? So where you will get this value 700? In the next field of P. So what you can do, you can write after the loop start is equals to P of next. Start is equals to P of next. So what it means? It is start. So you are assigning P of next, that is 700, to the start. So this is not your start. This become your starting point. Okay, but you want to delete these connections, right? So P of next must be null. If you want to delete this node, it should be null. So P of next must be null. So that will be your next line. That is P of next is equals to null to break that connection. So you just broke this connection. Okay. Second, this connection has to be deleted again. So starts previous node. Now this node is represented by a start. So start previous node should be null. So you will be writing starts, new starts, previous node is equals to null. And this is how you just separated the node from the existing doubly linked list, and this is your new starting point. So this is the case of deletion of new node from the beginning of the list. And your final list will become like this. This is new 7 node, sorry, null 7 200. The address is 700. This will be your starting point. This will be 700, so it is pointing to the previous. This is pointing to the 200. This is 2, it is 800, so pointing this to the next. This is pointing to the 200, 8 null and 800. So this is the new doubly linked list after deletion of a node from the beginning of the list. Now let us discuss about if you want to delete a node from the end of the list. Deletion of a node at the end of doubly linked list. So again we will be having a delete function and it will receive the data. While writing the code we will be writing it combinedly, but while writing the algorithm we have to write these steps again and again. So the very first thing you need to check it, which we have previously done, that if my start is equals to null. So what it means, we do not have any list, so you will be displaying one message that it's a empty list. And if it is not the case, then what you need to do, you need to search the particular element which is to be deleted. So let's assume that the user has sent a data 8. So you need to search for that. So how will you start? You will be assigning your starting point to the P, and you will be moving forward. By checking P's info is not is equals to your data. Till then you will be moving forward. So P is equals to P of next. This is the case we have written everywhere. And if while moving forward you will found that your P becomes null, if P becomes null, you will be displaying one message that data not found. Data not found. This is what we have just discussed. Okay. And then you will be closing your loop here. Fine. Now let us check the condition that data is 8, P is at the starting point, P's info is 5. So 5 not equals to 8. So P will be moving forward. So P of next will be copied to the P. So P of next is 700. So P will be copied here. P of info is 7. So 7 will be compared with 8, which is not equal. So P of next, that is 200, will be copied into P. Okay. Then P's information is 2. So it is 2. 2 is not equals to 8. So P of next will be copied to the P. So P of next is 800. So copied into P. Okay. Then P of info is 8. Now 8 is not equals to 8, false. So you just identified a node which is to be deleted. Now when you delete this node, what will happen? The previous node 200, whose address is 200, whose next field should be null. So how your new list will look like? It look like this. It is 700, it is 500, starting point remains same, then it is connected to this, and if it is connected to this, so it should be 500, it is 700, it is 200, it is again 700, then here it is 700, it is 2, it is 200, and it is 800. So 800 should not be there. If you delete the last node, what will remain in the last node? Null. So this become your last node, right? This is 200, but we are not stored this address 200 any of the variable. We know a node which is to be deleted, we can make the previous field as a null, so this connection can be broken. But how will you break this connection? So to break this connection, what will happen? You need to remember this address. And how will you get this address? You need to get this address while moving P to the next position. Means when you were at the 500, you are moving from 500 to the 700. So you need to copy this 500 in some variable. So when you are at the 700 and you are moving from 700 to the 200, so you must copy this 700 to the other variable. So what we'll do, this is the line where you are moving forward, right? So before moving forward, take one more pointer and copy the previous address of P. So what will happen when you were at the 200? You are copying the address of P to the Q, so it becomes Q, and then P of next, that is 800, you copied into the P, so this becomes your P. Now if you delete this node, so previous node is your last node which is pointed by q. So what you want to do, q's next must be null. So after this loop you will be writing q's next should be null, and to break this connection p's previous should be null. So p's previous should be null. And so after deletion of this entire thing, so the the node will be looking like this. So it should not be on 200, it will becomes null, and it is 800. So you just separated the last node from the existing list. So this is the logic for deletion of a node from the end of the list. And you can remember easily that these steps are common just to search the element or node. Now let us discuss about deletion from the middle of the doubly linked list. To delete a node from the middle of the list, so we have to check same conditions again. So we will be checking it. If your starting point is, it should be double equals to null. If starting point is equals to null, it means that you have a empty list. And if it is not the case, then you need to search that particular data. Suppose that data is 2. So we'll assigning the starting address to the p. So this will be our starting point, which is storing the address 500. Then we'll be checking the data. So same like in the previous case, we'll be writing p's info if not is equals to your data. You will be keep moving, but before moving forward you will be copying current p's address to the queue, and then you will be moving p is equals to p of next. And then in between somewhere, suppose p becomes null, then you will be displaying one message that data not found, and then we'll stop. So this is a procedure to search the element, search the node or element, right? So we are assuming that this is p, the 2 is the data which is to be searched. So p's info is 5, data is 2, which is not equal. So p of next will be copied into p, but before that p's is copied into q. So this becomes q and this becomes p. Then again p's info, that is 7, which is not equals to 2. Copy p into q, so it becomes q. Copy p of next in p, so p of next is 200, so p will be here. Now what is p's information? It is 2. Now 2 not equals to 2 false, so you identified a node which is to be deleted. Now when you delete this node, what will happen? In the queue's next field here, you must store the address of 800, but you do not know 800 is stored in which variable. So what you need to do, you need to copy this address some new variable. So out of this loop you will be creating another variable, suppose r, and you are writing p of next to r. So what it means, p of next is how much? 800. You copied it into r, so it becomes your r. Okay, and now if you delete this node, so how your list will look like? It is null, it is 700, so it is pointing to this. If it is pointing to this, it is 500. And if you delete this node, so here what should be there? It should be 800, right? It should be 800, so it will be pointing to this node. And what is 700? It is q. So q of next must be 800, and who is storing the 800? By r. So after this line you can write q of next is equals to r. What you have just done, q of next is equals to r, that is 800, and these nodes are connected. Done. Then what you need to do again, r should be connected to the q. So to make this connection you need to write r's previous field should be q, that is how much? 700. So you will be writing r's previous field should be q, so that is 700, and you need to make these two fields as a null to break this connection which is pointed by p. So you will be writing p of next is equals to null and p of previous is equals to null. So you are just break all the connection with all the nodes, and this is how you delete a node from the middle of the list. So these are the algorithms, and now let us implement this algorithm into the code. So before that you should close your else here, and we'll write this code in the next video.